In earlier sessions, we covered why Solana treats time as a first-class problem and how consensus works. But solving time is only the beginning. Once you have a shared global clock and fast finality, the next challenge is scale. How to process tens of thousands of transactions at the same time without bottlenecks. Most traditional blockchains execute smart contracts and transactions one at a time, in sequence. That creates a natural choke point. Lots of users compete for the same limited processing capacity. Solana's architecture tackles scale by rethinking how transactions are forwarded, executed, and propagated across the network. The core pieces of this design are C-Level, Gulfstream, and Turbine, each addressing different dimensions of blockchain throughput. Let's start with C-Level, because it's arguably the most fundamental departure from traditional blockchain execution. In traditional platforms like Ethereum, smart contracts are executed sequentially, one transaction at a time, even if they don't interact with the same state. That simplifies reasoning, but it doesn't take advantage of modern hardware. Solana's C-Level runtime breaks this mold. Instead of serial execution, C-Level allows many transactions to execute in parallel, as long as they don't conflict with each other's state. Validators examine the accounts each transaction will read from or write to, and when there are no overlapping dependencies, those transactions can run concurrently across multiple CPU cores. This has profound implications. A well-designed Solana program with non-contending state can be executed simultaneously on many cores, dramatically increasing throughput. It's not just about pushing a few transactions through faster. It's about changing the way execution scales with hardware. Validators with powerful machines can execute hundreds or thousands of operations in parallel, rather than being limited to a single thread of work. For builders, C-Level means you can think about your application in lanes, where independent sequences of activity don't have to wait for one another. That's essential for things like high-frequency DeFi, real-time gaming, and the complex marketplaces where many actors interact at scale. Next up is Gulfstream, Solana's approach to managing transactions before they're included in a block. In most blockchains, transactions wait in a mempool, a shared queue where unconfirmed transactions pile up and nodes fight to include them in the next block. That system doesn't scale well when you want to target tens of thousands of transactions per second. Solana replaces that approach with Gulfstream, a mempool-less transaction forwarding protocol. Because the network already uses a deterministic leader schedule, where every validator knows in advance which node will produce the next blocks, transactions can be forwarded directly to anticipate leaders before their turn begins. Think of this as a kind of predictive routing. Wallets and validators push transactions toward the block producer ahead of time, instead of dumping them into a shared pool that everyone has to scan. This reduces network memory pressure, confirmation latency, and redundant gossip overhead. Validators can even execute these forwarded transactions ahead of production, preparing them for immediate inclusion once it's their turn. It avoids congestion and keeps the pipeline full, which is essential when you're targeting sustained high throughput. For builders, Gulfstream means your users' transactions don't just sit in a queue waiting to be picked up. They're proactively routed to where they will be included, dramatically improving throughput and responsiveness. Even after transactions are executed and included in a block, the final job is to propagate that block quickly across the network so other validators can verify and vote on it. That's where Turbine comes in. Inspired by peer-to-peer file-sharing protocols like BitTorrent, Turbine breaks each block into small packets and distributes them across the network in an efficient, hierarchical way. Instead of one node sending the entire block to all other validators, which doesn't scale as the network grows, Turbine sends slices of the block to subsets of nodes, and then those nodes forward packets to others. This creates a tree-like propagation pattern that can reach thousands of nodes quickly without saturating any individual connection. This optimized propagation is critical because slow block dissemination slows everything else down. Turbine keeps the network synced and validators informed, enabling fast confirmation and finality even as the validator set grows. For builders, Turbine is one of those invisible pieces of infrastructure that you benefit from without seeing, but its impact is real. Blocks propagate fast, validators stay coordinated, and the network can support high transaction volumes without high latency. It's important to emphasize that C-level, Gulfstream, and Turbine aren't isolated optimizations. They work together. C-level lets the network execute non-conflicting transactions in parallel. Gulfstream makes sure transactions reach the right leader quickly without waiting in mempools. Turbine ensures that once blocks are produced, they are disseminated across the validator set as efficiently as possible. Together, these innovations dramatically reduce bottlenecks at every stage of transaction processing: admission, execution, and propagation. That's why Solana can reach sustained throughput figures that are orders of magnitude higher than traditional blockchains that process transactions one at a time and rely on broad gossip protocols. Importantly for builders, this design means you can think about high-frequency, high-volume applications like real-time financial markets, multiplayer games, or interactive consumer apps without wrestling with long queues, slow confirmation times, or severe bottlenecks during peak load. If there's one idea to remember from this session, is that scaling isn't just about bandwidth or hardware. It's about architecting the pipeline. From the moment a transaction enters the network to the moment it's confirmed by validators. C-level rethinks execution by enabling parallelism. Gulfstream rethinks transaction routing by removing the need for mempools. Turbine rethinks block propagation so that scaling doesn't cause latency. Together, these innovations help Solana support thousands of transactions per second during real-world use. And under specialized stress tests, the network has demonstrated peaks into the tens of thousands or even over 100,000 TPS, without fundamentally compromising finality or user experience in the scenarios those tests target. In the next session, we'll turn from scale to data, how accounts and storage fit into this high-throughput world.